Good afternoon to all. Today we are just starting the fourth SEM. I am just starting the second module. The title of the module is the stereochemistry. Today we are just introducing the stereochemistry. Stereochemistry means it is a branch of the chemistry which deal with the spatial arrangement of the atom or a group of atom in a molecule in a three-dimensional space. And the stereochemistry also deal with the effect of this arrangement of an atom or a group of atom of a molecule on the chemical and physical property of the substance. And before that, before discussing the stereochemistry, we have to first know what are the isomers. Isomers means they are the organic molecule having the same molecular formula, but they are differ in many of the features. So the isomers can be divided into the two different type of the category. First one is the structural isomerism and the second one is the stereoisomerism. And the structural isomerism means they are isomers but they are differ in the structures. And the structural isomerism is otherwise known as the constitutional isomerism, and the structural isomerism can be subdivided into four different type of the category. First one is chain isomerism, second one is positional isomerism, and the third one is functional isomerism, and the fourth one is tautomerism. And the next category is the stereoisomerism. The stereoisomerism means the isomers which are having the same molecular formula but they are differ in their spatial arrangement of the atom. And the stereoisomerism can be subdivided into the conformation and the configuration. Conformation means it is the stereoisomers which arises due to the free rotation of the sigma bond. And the configuration which is also a stereoisomers which is formed by the chemical bond breaking and formation of the chemical bond in a chemical reaction, and due to this formation and breaking of this chemical bond there is a difference in the spatial arrangement of the some group of the organic compound. And this configuration can be divided into two different categories, geometrical isomerism and optical isomerism. And the geometrical isomerism is arise due to the restricted rotation, and optical isomerism arises due to the property of some of the organic molecule towards a plane polarized light. And before we discussing the stereoisomerism, we have to first we have to discuss the structural isomerism and its classification. As we discussed earlier, the structural isomerism can be subdivided into the four different categories. First one is chain isomerism. Chain isomerism means the isomers which are differ in their chain length but having the same molecular formula. See here the example is given. The example is C5H12. If you are arranging linearly, the first one is the linear arrangement of the molecule. Second one is the branched structures of the same molecule. And the next category is the positional isomerism. Positional isomerism means the sum of the organic molecule contain the functional group, and the functional group are attached to the hydrocarbon but they are differ in the position. See here the example. First example is the butane 1-ol. And for the butane 1-ol, the OH group is attached in the terminal position, whereas in the butane 2-ol, the OH group is attached in the second position. And the third category is the functional group isomerism. Functional group isomerism means the stereoisomers, but they are differ in the functional group. For example, alcohol and ether. Both of them have the same molecular formula, but the functional group in the alcohol it is OH, whereas in the ether that is the O. Okay. Next is the fourth category, that is the tautomerism. We are heard about the keto tautomerism. Keto form. Ketone means it is a keto group. C double bond O group is present. Enol means enolate form. Keto enol tautomerism. We are already studied the keto enol tautomerism in the case of ketone. Now, the stereoisomer can be subdivided into configurational and conformation. As we discussed earlier, the conformation is formed by the spatial arrangement of the atom or a group of atoms due to the free rotation of the sigma bond. And the configuration means it is the three-dimensional arrangement of the atom which is formed by the chemical bond breaking and or making of a chemical bond in a chemical reaction. And the configuration can be subdivided into geometrical isomerism. Geometrical isomerism is arise due to the restricted rotation of the double bond, and we are already studied the cis and trans isomerism. The next category is the optical isomerism. Optical isomerism again subdivided into enantiomers and diastereomers. And enantiomers means they are the stereoisomers, but they are non-superimposable to each other. And diastereomers means they are not related to as a mirror image. Thank you.